Hey, today we are going to be talking about solving simultaneous equations, and we're going to use a technique that we call substitution. Now, simultaneous equations just means I've got two equations happening at the same time and I want to solve them. In other words, I want to find out a value for x and a value for y that makes both of these true at the same time or simultaneously. So first thing I'm going to do is I'm going to label these. I'm going to pick one of them and call it equation 1. We'll call the other one equation 2. It doesn't matter which is which. It's just so that we can know which one we're talking about. Now you'll notice both of these equal y. This bit equals y and so does this bit. So in other words, these must be the same as each other, because if they're both y, then they must be the same as each other. So if I was to write that out, it would look like this. Well, this bit equals y. This bit also equals y, so I can take the y out of the middle and they equal each other. Now, if you notice, I've only got one unknown, which means I can solve it. I can use my algebra skills, my sliding and changing to find a value for x. So let's do it. Looking at that, I can see the smaller of the pronumerals is this one, the negative 3x. I'm going to drag that across to the other side. Okay, because I've only got the one unknown. So when I drag it, when I drag it, let's write it. I'm going to drag it across, it becomes its opposite. So when I drag that across, it becomes a plus 3x. I'm trying to get the letters on one side and the numbers on the other. So this minus 8's got to go. When I drag the minus 8 across, it becomes its opposite. In other words, a plus 8. Now I can tidy this up. I've got 10 on the left-hand side. I've got 10x on the right hand side, and we're nearly there. This is now like a simple solving, a one step. This times 10, I drag it underneath, becomes a divide 10, and I can calculate a value for x equals 1. 1 equals x, which is the same thing as x equals 1. It doesn't matter sort of which way around you present that. X equals 1. We're nearly there. We've found a value for the x. Now, how do I find a value for the y? Well, I'm going to take that and I'm going to substitute it into one of the equations. It doesn't matter which one. In this case, I'll pick number 2. 7x minus y equals 7x minus 8. Now I know a value for x, so I'm just going to substitute it in. Wherever I see the x, I'm going to replace it with a set of brackets, and in there I'll put my value of 1. Let's calculate it. Y equals 7 minus 8, which is a negative 1. We're done. We've got a value for y equals negative 1. We've got a value for x, which equals 1. And they are my solutions. The solution in this case is x equals 1, y equals negative 1. And if I was to write that in sort of coordinates form, it would look like that. Because remember, we always have the x value first, then the y value. Whew! There was a bit in that, but hopefully you can see the process is using a lot of ideas that we've already covered in previous videos. Let's have a look at one more, because this one's a bit different. We don't have two equations that both start with y equals. So I can't quite use the same technique that I just used, but I can use substitution. Here are my two equations. Let's call this number 1 and this number 2. Now look at number 2. Something here is really handy for me. It's y equals and then this bit. It tells me what y equals. Well, that's great, because I can take that and I can substitute it into 1. I can replace the y with this bit. So let's write equation 1 out again. Wherever I see the y, I'll put a set of brackets. And I know that y is x plus 3. So I'll replace the y with x plus 3. I'll put it in there. Great, there's only one unknown here, and this is what I'm trying to get to so that I can now solve for x. But there's some brackets in there, so I need to expand the brackets before I solve. So let's do that. Negative 3 times x will give me negative 3x. Negative 3 times positive 3 will give me negative 9. So when I do the expansion, my equation now looks like this. Negative 3 times x and negative 3 times 3. So that's those bits. Now it's just tidying up. I want the letters on one side, the numbers on the other. So this negative 9's got to go. When I drag it across to the other side, it becomes its opposite, plus 9. Let's tidy everything up now. I've got 2x, take away 3x, leaves me with a negative 1x. We don't write the ones, so it's just a negative x. And my negative 8 plus 9 equals 1. Now, we're almost there, but I've got a small problem. negative x equals 1, but I want x, not negative x. Now here's this little pro tip. If you want to change the sign of this from a negative to a positive, just go ahead and do it. But you have to change the sign of the other terms. So in this case, if I make this negative a positive, this positive one will become a negative 1. Great, I've got a value for x. Now, just like we did in the previous example, I can take that and substitute it in to another equation. In this case, I'll do number 2 because it looks nice and easy. So let's write equation 2 out. I'm going to put a set of brackets where the x was, and in that place, or substituting in, I'll put this value of negative 1. Now I can just calculate a value for y. Negative 1 plus 3 gives me 2, and we're done. I've got my value for x, I've got my value for y, and that is my solution. Or if I write it in the coordinates form, it'll be negative 1, 2. Congratulations, you guys. You just solved some simultaneous equations using substitution. Well done.